That means the separation process depends mainly on the size. That means the molecules which are having bigger size will move faster, and the molecules which are having smaller size will move slower. Actually, this is against the natural phenomenon. In the natural phenomenon, usually smaller molecules will run faster, and bigger molecules will run slower. That is the natural phenomenon. Okay? But this is opposite. It is opposite to the natural phenomenon. That means the bigger molecules will run faster than the smaller molecules. But whatever it may be, the separation is completely depends on size of the molecules. Size of the molecules. So in this chromatography, it is size-based separations. Size-based separations. It is non-interactive separation. That means ideally no adsorption. No adsorption. Ideally there is no adsorption. Usually in the chromatography there will be many interactions. There will be adsorption, there will be desorption, solubility, van der Waals forces, and also we have electrostatic attractive forces, something like that. But in this case there are no such interactions. Here mainly the separation depends only on the size. It is like molecular sieving. Molecular sieving. I think you have idea about siever. Idea about siever which we are using at home for sieving. For example, if you have some flour, gram flour or organic flour or something like that, if you see any impurities, you are using a siever. You are keeping the material and doing like this. When you are shaking this one, the smaller particles will penetrate to the pores of the siever, and the bigger particles will remain on the mesh of the siever. Okay? That's how you are doing it. In the same way, we can say this one as molecular siever. Molecular siever, it depends only on the size of the molecules. But the main problem here is, main thing here is, it is opposite phenomenon. Opposite phenomenon. That means bigger molecules will move faster, smaller molecules move slower. Why they are doing like that? Why it is against natural phenomenon? I am going to explain that one also, one after another, under principles. Separation is based on molecular size. There is hydrodynamic volume. Hydrodynamic volume means, for example, if you have an ion here, Na+, okay, there will be solvation. You have idea about solvation. For example, if you consider Na+ presenting water, okay, it is surrounded by solvent molecules because of solvation. Hydrodynamic volume means the volume of entire space. Okay? Hydrodynamic volume means it is the volume occupied by both ion as well as the solvation sphere around the ion. That is the net size of the ion. Stationary phase is a porous gel. Porous gel particles. Porous gel particles means particles which are having pores. And the pores are of two types: hydrogels, xerogels. Hydrogels and xerogels. Hydrogels means the particles are soft, smooth, in which they are having water in it. Okay? Xerogels. Let me show you. Here, I kept here image here. These are silica xerogel beads embedded with iron oxide. Okay, so the beads are looking like this. These are xerogel beads. Okay, they will look like this. Right. So we have hydrogels. When it comes to porous gel particles, we have hydrogels and zero gels. Hydrogels are small, soft and smooth, in which there is water content, whereas zero gels are hard beads. Okay. Solvent. The mobile phase is solvent, any solvent, aqueous or organic. Larger molecules elute first, smaller molecules elute later. Okay. Larger molecules elute first. Elute first means larger molecules are running faster than the smaller molecules. Okay. For example, if you have the size of the particles like this, if you have size of the particles like this, smaller, medium and bigger. Okay. The bigger one will come out first. Okay. And then this medium size particle, we can say molecule, medium size molecule, and smaller size molecule will come at the end. Three bands. One band for this one, second band for this one, third band is for this one. That means in the chromatograph you will be having three peaks. One peak is for this, one peak is for this, another peak is this one. And when you see the chromatograph, you will see a peaks are like this. Okay. This peak is corresponding to this one. This peak is corresponding to this one. This peak is corresponding to this one. Because this is a x-axis is time. X-axis is time. Y-axis is detector signal. X-axis is time and y-axis is detector signal. Did you get the point? Yes. So the molecule which is spending shortest time in the column is the biggest molecule, and then medium and then small. Now I am going to tell you why this is happening. Let me explain to you. The stationary phases are having pores. Different stationary phases are having different pore sizes also. Right? Now, when the molecules are passing, the smaller molecules will penetrate inside the stationary phase particles. Inside. They will penetrate. When they penetrate inside, they will sit there for some time. Okay? In each particle, they will spend some time because it is penetrating inside. Whereas the bigger molecule, because molecule is bigger, pore size is smaller, and it cannot enter. Okay? It cannot enter inside. If it is not entering inside, they will come directly from the periphery of the particles. Periphery means outside. Just outside of the particles they will move. They will move without entering inside the porous beads of the stationary phase. Okay? Because they are not entering, they will move faster. They will move faster along with mobile phase. Okay? Whereas the smaller ones will penetrate deep inside. However, medium. They will penetrate, but not too much. The penetration will be little. Higher the penetration, deep inside penetration, slow movement. Okay? And if they are moving from the periphery of the particles, then they will move very fast. Let me explain to you this one by using one small picture. You can see here. You can have a look here. This phenomenon is well explained by this image. You can see here. We have three particles, size of the proteins. You can see. This is bigger, medium, smaller. Okay? And these are the porous beads. Let me maximize this. Okay? These are the porous beads. And they are having more pores. You can see. These are the pores. And when they are passing through the column, you can have a look. The bigger ones are not entering and they are moving faster. You can see at time, at shortest period, the biggest molecule are coming out. Okay? But still, you can see here, the smaller ones are penetrated inside the porous beads. And they will move slowly. This is for peak for first, the large sized molecule. This is peak for medium sized molecule. And this is peak for small sized molecule. Did you get the point? So, if you understand this concept, it will work accordingly. Already I explained about hydrodynamic volume. Hydrodynamic volume is effective volume of a molecule or particle when moving in a fluid. It includes the physical size of the particle and the surrounding solvent molecules that move together with it. This is what I already explained. It is there. Okay? Now working principle of gel GFC. That means gel filtration chromatography. We can say we are having different names for this chromatography. GFC means gel filtration chromatography. Gel filtration chromatography. And we can also say GPC. GPC means gel permeation chromatography. We have also another name, SEC. SEC means size exclusion chromatography. All these names are the same chromatography. Gel permeation chromatography. Okay? Gel permeation chromatography. Size exclusion chromatography. That means the molecules are excluded to enter inside. Molecules are excluded from entering inside the porous particle based on the size. That's why size exclusion chromatography and also gel filtration chromatography. Okay? Names are different, but the technique is the same. Okay? One name is based on the mechanism, other name is based on this stationary phase, other one is based on mobile phase. Okay? Right. The working principle of GFC is based on differential access of molecules to pore volume of the stationary phase. Did you get it? Based on differential access of molecules to the pore volume of the stationary phase. Differential access. That means smaller molecules are having more access to the pores. Medium molecules have less access to the pores. Bigger molecules, no access at all. That means bigger molecules are moving without entering to the pores. Okay? Right. Large molecules are unable to, we can see, large molecules are unable to enter the pores. Therefore, travel through the interstitial spaces between the beads. They experience the shortest path and elute first at the wide volume. The biggest ones will be eluting faster. Medium sized molecules partially enter the pores and thus experience intermediate retention times. That means not too early, not too late. Okay? Are you ready? Not too early, not too late. That means there will be in the middle peaks. The earliest is largest molecules. Okay? And then medium sized and then smaller ones. So completely, if you have 10 types of molecules, the sequence will be the biggest one will come move faster and then smaller than that and then smaller than that, smaller than that, smaller than that. In that sequence they will come one after another. Complete separation process depends on size of the molecules. So, is it clear? Small molecules penetrate most. All of the pore volume resulting in the longer residence times and later elution near the total column volume VT. Okay? That means that is the one which is spending a lot of time. That means that will be the end. The last one. Okay? Here we are seeing two things. Wide volume. Wide volume means when this is coming out fast. That means it will go along with the mobile phase. Solvent front. That is V0. And we have total column volume VT. VT is equal to, I am going to explain to you later. We have also, let me go otherwise there to show you. Yeah, VT is equal to V0 plus VI, where V0 is wide volume, VI is internal pore volume. Wide volume means the volume of the column between the particles. The volume of all the column packing between the particles. When it comes to internal pore volume, that means it is regarding stationary phase. In the stationary phase, there are pores. Total pore volume is a internal pore volume, that is VI. V0, VI. And total column volume, VT. Total column volume is VT is equal to V0 plus VI. V0 plus VI. This is what it is showing here. Right. Yeah, the mobile phase flows continuously. Of course, when we are saying chromatography means it is common. We have stationary phase, we have mobile phase. Mobile phase will be pushing the molecules to pass through the stationary phase. Okay. While they are moving in the stationary phase, they will migrate with different migration rates, which makes them to get separated. Is it clear? So, mobile phase continuously flowing. Molecules are separated purely by hydrodynamic volume. That means volume of the particle along with the solvent. That means that we can say that is called as effective size. Effective size of the molecule. That is hydrodynamic volume. Detector response produces a chromatogram correlating elution volume with molecular size. You can see. That means here the chromatogram. The normal chromatogram is so, let me explain to you. Normal chromatogram, time versus detector signal. When it comes to gel permeation chromatography, you can see detector response produces a chromatogram correlating what? Elution volume with molecular size. That means this is elution volume, this is molecular size. Okay. So in this case, we are getting a chromatogram like this: elution volume on the x-axis and molecular size on the y-axis, and you will be getting the peaks will be same. Something like this. Okay? You can see. That means there are four compounds with different sizes. Don't think that because this is big peak, it is bigger size molecule. No. Okay? Now, which peak is corresponding to biggest size molecule among four? This one. Okay? The one which is coming out first is the biggest molecule. Okay, size is bigger, and the smallest, that means the one which is staying more time in the column, more time in the column, that is the smallest, right? So now you understand about how the chromatograph come out. So porous beads act as molecular sieves. So it will be sieving molecules. But the sieving phenomena is opposite to natural phenomena. Okay? Bigger molecules will go faster and smaller molecules slower. Molecules distribute between interparticle volume and intraparticle pore volume. Interparticle volume means volume between the particles. For example, if you see here, if you have a look here, this is the gap. For example, this is the gap. This volume of the gaps, okay, is interparticle volume. Intraparticle porous volume, that means intraparticle pore volume means the volume of the pores. You can see here, these ones, this part, this volume. Okay, that is the difference between interparticle volume and intraparticle pore volume. Usually the smaller molecules will go to distribute more. Molecule distribution. Of course, I am going to explain to you also distribution constant in the later slides. Distribution constant, I am going to explain to you. So usually solute molecules will distribute between stationary phase and mobile phase. We know very well. That means if you consider a solute A, it will distribute between stationary phase and mobile phase. If you consider a solute molecule A, that will distribute between stationary phase and mobile phase. If this is equilibrium, okay? If this equilibrium towards this one, it will run slower. If this equilibrium shifting this way, it will run faster. For small molecules, this one is more than for small molecules, this one is more than this one. It will move slowly. For bigger molecules, this will be more than this one. That means the equilibrium shifting towards left, towards mobile phase. Okay? So no chemical affinity involved. No chemical affinity means no any interactions like hydrogen bonding, electrostatic interactions, okay, van der Waals forces, adsorption. There are no such kind of interactions, okay. Separation on the basis of size and shape. Shape also important parameter here. Size and shape. So a molecule may have a spherical shape. A molecule may have this shape, okay, elliptical shape, okay. The shape also matters. Because to enter into the pores, size and shape matter. The first factor is size and then shape also. Okay. Analytical example, protein having larger size do not enter the pores of the gel, therefore get eluted faster. It is the same because proteins are big size, large size molecules. Protein is a polymer. It is a polymer. We can say that one as also polypeptide. Because there is in protein we have there is a lot of like this CO and H bonds. CO and H. This is called peptide bond. Polypeptide is nothing but protein. I think those who came from biology background may be having more idea about this. Okay? It is a big size molecule, the protein. So that's why they do not enter the pores of the gel and therefore get eluted faster. Unlike having small size, penetrates the gel beads, therefore get eluted slowly. Okay? Right? Already have idea about that point. Now we are coming to instrumentation. Instrumentation of gel filtration chromatography, gel permeation chromatography, or size exclusion chromatography. Of course, similar to all other chromatographies, the parts are same. Because we need solvent as a mobile phase. That means we need to have mobile phase reservoir, and we need to have pumping system to pump the solvent, sample injector in order to inject the sample, GFC column, gel filtration chromatographic column, detector, data system. Almost all the chromatographies having the same parts, but inside components may be different. For example, column is present in column chromatography, gas chromatography, HPLC, in all the chromatographies except planar chromatographies. In all the chromatographies we have column. Okay? But inside the column, the stationary phase will be different. Inside the column, the stationary phase packing will be different. Is it clear? Mobile phase reservoir, it contains solvent that used to transport analytes through the column.